I know that you must be anxious to start solving these problems, but we need to have a clear idea of what is a system of linear equations. So if you connected linear equations to y equals mx plus b, you are on the right track because that is the equation of a line. Now, if we have the word system, think about a group. Think about a group. So this means now that we're dealing with a group of equations. For this lesson, we're gonna be working with only two equations simultaneously. So for that, I want you to write this down. Our essential question here will be when does the system have one solution? When does the system have one solution? Okay, and I want to give you some visuals here. If we have a linear equation, that means we have a straight line. But if we have two linear equations, then that means we will have two straight lines. And if these two straight lines were to cross at some point, then that point of intersection will be their only place in common, correct? So because these are straight lines and their endpoints go in different directions, there is no other place where these lines will cross again, correct? So we can conclude that a system of linear equations will only have one solution if and only if the lines were to intersect. So let me write this down. At this point, of intersection, if we were to locate this point, we will need coordinate values, right? So those coordinate values will be x and y. So graphically, this is how you will see the solution of the system. But algebraically, in numbers, we will have to find the value of x and the value of y. There is no other number but this specific number for x and y that will satisfy both of your equations. Because they only meet at that point, there is only one unique x and y value that will satisfy the equation as well. So let me leave you with this statement right here. I'm gonna say if the system has one solution, then the graphs of these two equations intersect at exactly one point. Okay, I'm going to read this again because this is our final statement. This is our conclusion. This is our statement. If the system has one solution, then the graph of these two equations intersect at exactly one point. Okay, so I'm going to leave you with that. And before you start working on the next problems, I would like for you to answer these three questions. Okay, so pause the video and answer these three questions. Okay, so this is the first example, and this is how our system of linear equation looks. We have two equations right here, and notice that they're not in the traditional form y equals mx plus b. They are actually in standard form. Okay, so they're in this form ax plus by equals c. Because we're using the elimination method, we need the variables to be lined up. So we're gonna have xx and yy just because for the purpose of using the zero pairs. Okay, so you will see what will happen here. Now to solve the system, remember our goal is to solve for x and y. If we are able to solve for those coordinates x and y values, then that means we will have a point of intersection. And if we have a point of intersection, that means there will be a solution, one solution to the system. All right, so that's our goal. Our goal will be to solve for x and to solve for y. Now to do that, we're gonna follow these 3 steps. The first one, we're gonna identify a zero pair. So let's start with number 1 right here, and for that I'm going to rewrite my equations. So the first step says which variable is easier to make a zero pair and why. The zero pair, I can see here right away that it will be this one, because negative 4x plus negative 4x and 4x cancel out. So there is my zero pair. We can move on step 2. Step 2 says add both equations and solve. Which variable do we eliminate when we add both equations? So the elimination method is what it does. That's what the elimination method does. We eliminate one variable and then we solve for the next one. So right here, since this is a zero pair, we're going to eliminate this one. And now we can add our 2 equations. We're going to add our 2 equations. So that's going to be negative 2y plus ay will give us 6y equals negative 36. Okay, so the next step is to solve for the variable. Now we're solving for y. And since we're multiplying 6 times y, I'm going to do the opposite by dividing by 6 on both sides. So now y equals negative 36 divided by 6 is negative 6. Okay, so there is our first variable. Now that we have y, we can solve for x, and that is doing the third step. The third step says plug in. And what do I mean by plug-in? Now that we know what is the y value, we're gonna pick one of the equations. It says right here, which equation is easier to plug in to find the other variable. Okay, so it doesn't matter which equation we pick, but you wanna pick the easier one that it is that might be for you. For me, the easiest will be the one without the negatives, so that's the second equation. I'm going to pick the second equation, the original equation. Okay, second equation is 4x plus ay equals negative 24, and I'm going to plug in this y value into here. So now I have 4x plus a equals negative 24. Plug it in. So now let's simplify this. Is 4x plus negative 48 equals 24. Now I can solve for x. Solve for x, so add 48 on both sides. This cancels out, and 4x equals 24. Sorry about that. And divided by 4 on both sides. So x equals 24 divided by 4 is 6. So the x value is 6 right here, which means that we have that unique x and y value, which means that we have a point of intersection. And remember, if the system has a point of intersection, that means that the lines intersect. So they intersect only at one point, so we only have one solution. Okay, we have one solution at this point.